So in the yesterday class, we actually learned about different types of data types. Okay, so you saw like what actually data types are. So if you take this information like the name, the age, the country, the height, like does he like a football or something like that, the phone number, the email. So these are all different types of data types, right? So you saw this in here. So you saw this in here. So the name is nothing but text. Text is actually string data type in programming words. Okay, the number is either integer, and in integer we saw different types of integers like the normal whole numbers and the floating numbers. So we saw integers which are called int and unsigned integer which is called uint. Okay, so you have seen two different things in Solidity. And yeah, height numbers, yes or no boolean, and then the phone numbers and all these things, right? So we actually started with signed integers. So you saw signed
Now
integers.
recording.
Okay, you are also recording the this thing. Okay, Angela, hello. Is everything okay with your system now? Good. Okay, so I think we have the people in the class. So yeah,
Hi, good evening.
good evening. Is everything okay with your sister?
Yes, but she has not been discharged. I just rushed home to
Okay.
join the class, but I've not been able to go through yesterday's on.
Okay, okay. I'm not sure about yesterday's class, but today's class we will be having the recording session. So I'm not sure what we can do about yesterday.
Okay, it's fine. Thank you.
No worries. Sorry for that. Uh, okay, so we were talking about the data types, right? Different types of data types. Okay. Um, Even in that, we were only talking about Solidity data types. So data type, as I already told you, it's nothing but what kind of value you're trying to have into it. Okay. So the very first one is the signed integer. So in signed integer, you have something called int, okay? Plus and minus. Like you can either have a plus number or a negative number, positive number and a negative number. Okay. So this is one data type. The other thing that we discussed yesterday is unsigned integers. So in unsigned integers, it is actually called as uint. Okay, uint only can have plus symbols. Okay, so you can see in the program in this, you can see uint can only have positive numbers. You cannot give a negative number. So if you have given negative value, it will throw you an error. Okay, so this is the difference between a normal int and a uint. Okay, int is nothing but integer. So int is nothing but an signed integer, whereas uint is actually unsigned integer. Okay, so these are the two different things. Okay, now even in int and uint you have different of things. Okay, so int actually have something like int 8, int 16, int 24, int 32, something like that. Okay, so you have like this int 64. So I'm going to explain what does this mean. Int 256. Okay, for even for the uint you have something like uint 8, uint 16, uint 24, uint 32, uint 64, uint 256. Okay, so you can have this as well. Okay, so yeah, go on,
Rama,
OJ.
I think your screen
Oh,
went off.
okay, okay, okay. Yeah. So OG, what I would say is that can you actually stop recording the session for this one? I mean, the voice one, the bot one. Hypo. Yeah, I think that might be an issue, I guess. Okay, cool. Cool, 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 cool. It's out. Yes. Uh, okay. So guys, if you can't see my screen, immediately let me know so that I understand. Okay, I don't know what. Generally, we don't get this kind of an issues in the other classes, but yeah, I'm not sure. Anyway, we are recording this class along with the audio and the video, so you will get that. Okay, so don't worry. Now, coming back, what I'm trying to say is that even in int, you have these different types of things. Like int is, you can have int 8, int 16, int 24, int 32, int 64, int 256, something like that. So I will explain what does that mean. Okay. So if you go to the diagram, okay, so I'll remove this one. So when I'm saying int, you can have types of ints. Okay, so you can say int 8 or int 16 or int 24. Okay, or int 32 or int 64. Int 256. I think you also have 128 and 256. Okay, I'll explain this. Don't worry. I'm just showing you. Like even in int, you can have different types of things. So you can see here, if I say int, okay, I can say int 8. Okay, so you can see int 8, int 80, int 88, int 184, int 48, int 128. So I can have anything. Okay, so I can have this also. I can have int in b. Okay, I can say int 32 public c is equal to 10. Let's go like this. So int 64. Okay, int 128. These are the most used integer types, variables. Okay, data types. Okay, so these are the most used ones. Okay, so even in the integers, you can use like this, or simply you can say int public x, something like that. Okay, so now I'm gonna explain each and everything in detail now. Okay, so this is again very important for you to understand for the programming, not just for Solidity, but generally for programming. It's very important for you to understand this stuff. Okay, so if you go here, okay, not it. I think I already did that for you. Okay, yes. Okay, so you see how the computer generally thinks. Okay, so this is a computer. Let's say this is a computer. Okay, so as I already told you, computer can only understand numbers. It can only understand 0 or 1. It cannot even understand 2. That's the thing. It cannot even understand 2 or 3 or 4. It can only understand 2. One is 0, the other one is 1. It can only understand either 0. So either it is 0 or 1. Okay, so 0 generally means light off, 1 means light on. So that's how the the microcontroller chip, the semiconductors, everything work in the back end. Okay, so computer will always think in zeros and ones. It's a combination of zeros and ones. Okay, so as I already told you, now how do you actually, okay, so how do you actually give some sort of like, let's say you want the computer to learn from 0, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, and so on. Okay, so you want the computer to actually understand the numbers from 0 to like infinity. Okay, but how does it understand? Because it can only understand either 0 or 1. How will you make it understand 2,
Please,
3,
your room is off.
Okay, I will do one thing. I'll try to cancel. I'll try to restart my computer, and I will be again back in 1 minute. Okay. Okay. Okay, cool. So now the computer can understand either 0 or 1, but it cannot understand more than that. Okay. But how will you make the computer understand like the number 2 or number 3, number 4, like that till infinity? Or how do you make the computer understand letter A, letter B, letter C? So how does computer really understand these things? Okay. So this, the scientists, the computer scientists actually discovered a thing called binary system. Okay. So they have actually found out a system called binary system. Okay. So it's called binary system. So what does it mean? So it means, uh, so in computer, there can be one box. Let us say one box. Okay. Just the memory. It's the memory unit, but let's say it is just one box. Okay. So inside this box, okay, it's just one box. And inside this box, okay, so you have one second. Okay. Okay, so let us consider this as a memory unit. Okay, this is a memory unit. Memory unit. This entire green thing is actually a memory unit. Okay, so the one that you're seeing is a memory unit, and inside this memory unit you can actually store up to, I think, in each memory you can store something like what's the highest number, gigabytes, kb. So the maximum that you can save in one just a small memory unit is, let us say 1 GB. Okay, 1 GB of data. You can just one memory. Okay, not 1 GB. It's too much. 1 MB. Okay, so 1 MB is nothing, but it's called 1 megabyte. Okay, so this can maximum like 1 megabyte. Like how I can say is that, let us say a box. Okay, generally an Amazon parcel, the maximum weight it can take is, let's say, 10 kgs, like that. You can think like that. Okay, the maximum weight it can hold is 10 kgs. Similarly, the maximum memory that a small memory unit inside the computer can actually remember related to 1 megabyte. Okay, so 1 megabyte. Okay, now these boxes, are inside the memory unit. Okay, so these boxes are actually called as bits. So this one box is called a bit, and of course when we are using different things, it's called bits. One box inside the memory unit is called a bit. Okay, it's called a bit. Now these boxes can either have 0 or 1. So this box can have 0 or 1. This box can also have 0 or 1. This box can also have 0 or 1. On this box can also have 0 and 1. Okay, so is everything clear until this point? Make sense? Everyone, just give me a thumbs up so that I know you until this point. Yes, OG, Angela, Christabel is gone. Okay, close stream. I'll share my screen. Okay. So yeah, Angela, all okay? Christabel, all okay until this point? Said yes. Angela, Christabel. Cool, sweet. Christabel, because this is very, very important. That's why I'm asking you multiple times, because this is not only for Solidity programming language, this is also for other programming languages. So these are the basic concepts of programming. Okay, so that's why I want you to really feel everything. Okay, so I'll continue. If you have anything, let me know. Cool. So this is a memory unit. Okay, so this green part is a memory unit, and the combination of different memory units is nothing but the computer itself, the data, the memory of the computer, the whole computer. Okay, so these are like a small boxes inside the memory unit. So these are called as bits. Okay, these are called bit. One box is bit. The combination of boxes, obviously, it's called a bits, right? Okay. Now you see here, let us consider 4 boxes. So 4 is the least that you can have. Okay. So what I'm saying is that, so 4 is the least you can have. Int 4 uint k is equal to 5. Oh, okay. So this doesn't support 4, but generally 4 are the least in any programming language. Bits are the least one. Okay. So now you can see this is 0. This is also 0. This is 0, and this is also 0. So all the 4 are actually zeros. Okay. Because this is all zeros, the computer you have coded like in the chip level, like the semiconductor. Okay, so when all are zeros, what you're trying to say is that let us say this is the chip. Okay, so this is the chip, like semiconductor. Okay, so you said that if all are zeros, okay, if everything is a 0, then it means that it is nothing but the value is also 0. Okay, if all are zeros, then it is 0. It represents 0. So this is 0, this is 0, and this is 0, but this is 1. Okay, so this means the semiconductor knows that it is value 1. Okay, so generally what happens is that, okay, so what happens is that binary system, and we are talking about the memory. Okay, so what generally happens is that, so the first one is nothing but 2 to the power 0. Okay, and this is the 2 to the power 1. This is 2 to the power 2, and this is 2 to the power 3. Okay, so this is the binary system that we are talking. Okay, memory unit is the green color part. Okay, binary system, memory unit, and we are talking about these values. Okay, so 2 to the power 0 is equal to, does anyone know what's the value of 2 to the power 0? It is actually 1. Okay, does anyone know what's the value of 2 to the power 1? So it is 2. 2 to the power 2. Okay, so it is actually 2 into 2, 4. 2 to the power 3, which means 2 into 2 into 2. it is actually 2 2s are 4, 4 2s are 8. Okay. So I'm gonna say this 8, this is 4, this is 2, this is 1. Okay, so you can see 8, 4, 2, 1. Okay, so we are only talking about 4 bits as of now. Okay, we are talking in 4 bits as of now. So 2 to the power 0, because it is all 2 in number, that's why we are saying this is a binary system, because we are using the 2 to the power, we are using this as binary system. If it is actually 10 to the power, you know, it's like a decimal system. Decimal system is 10. Okay, 10, 100, 1000, something like that. Okay, now coming back here. Okay, so when you said all are zeros, the value is actually 0 here. Okay, I will also try to do coding here. This is better color. Okay, I will also give chip some sort of color to it. Okay, okay. So when you are saying that this value in the 8th position, I mean in this position, if it is 0, in this position is also 0, this position is also 0, and this position is also 0, the value is actually 0. Okay, so now if this position is 0, this position is 0, this position is 0, but this one is actually 1. Okay, so it's like ticking the box. This box is ticked, which means that, so you can see the value is actually 1 here. Okay, so the chip will understand, okay, the value that the person is trying to say is 1. Okay, so how do you represent this? If everything is 0, 1, 2, 3, 4, it is actually 0. Okay, yeah. Okay, so when all are zeros, this is also 0. When first 1, 0, 0, 0, 0, 1, that means this is actually 1. Okay, because you can see 1, this has been highlighted here, 1. Okay, so now how do we represent 2? Okay, so this is very interesting. 2, you can see 2. Okay, because it is 1, you can actually represent 2 here. Okay, so this will become 2 when this is 0 and this is 1. Okay, so 1. Now how do you represent 3? Okay, so now this value is actually 2. Okay, now how do you represent 3? So you can see that 1 plus 2. Okay, so just I will try to remove this one so that it won't confuse you. Okay, so this will not confuse you. Okay, so value 1, 2, 4, 8, and then you will have 16, 32, 64. You will have that, that like arithmetic progression. Okay, I will explain about that in later bits, but for now, just we are talking about 4-bit system. Okay, 1, 2, 3, 4. Okay, so 1 place, 2 place, 4 place, 8 place. Now we are talking about number 2. That is okay. So how can we represent number 3? So you can see here, you can keep this one 0, this one also 0, this one is 1 because it is 2, but this one also will become 1. Okay, when you have said this one as 1 and this one as 1, the chip will think, okay, 2 plus 1, whatever the value, that will be 3. Okay, so that's how you actually get it. Okay, so 3 can be represented as like this: 0, 0, 1, 1. Okay, so clear until this point how I represented 0, 1, 2, 3, everyone? Until this point? Yes? Yes, cool. I think Angel and Christabel, everything is okay. Okay, I'll try to continue. If you have anything, you can stop me in between and you can ask. Okay, but please, again, if you didn't understand anything, just stop me in between and try to ask me, because once I have gone very far, if you really ask me anything in between, it will be a waste of time. Like a lot of time will be wasted unnecessarily. Okay, please feel free to ask me like whenever you don't understand anything right at that moment. Okay, please, that's a request from my side. Okay, cool. Now, how do you represent the number 4? Okay, how do you represent the number 4? So this is like a game, right? So you can see, okay, this is 0. Okay, 4 we already have, so we can say 1. There is no need for 2 and 1. The chip will understand, okay, because this has been highlighted 4, that is 4. Okay, I'm just checking in between so that my screen is shared or not. I'm just checking. Okay, don't worry about that. So you can see this has been highlighted 1, which means the chip will understand because the number 1 is nothing. So just remember, 1 means the bulb is on, 0 means the bulb is off. So 1 means the bulb is on, 0 means the bulb is off. So the chip will understand bulb on, bulb off. Okay, so now you are actually having a bulb on the 4th one. Okay, that's why it knows that, okay, it's number 4. Okay, so number 4. So this will be 0, this will be 0, this will be 1. Okay, 0, 1, 0, 0. Now, how do we represent number 5? So 8 can be 0, 4 can be left like that. So 4, okay. 2, there's no need for 2, but 1 can become 1. Okay, so the bulb is on the 4th position and the 1st position. 4 plus 1, the chip already knows that, okay, it's nothing but 5. Okay, so that's how you can represent this one here. So 5 can be represented as 0, 1, 0, 1. Okay. Now, how do we represent number 6? So 8 can be 0, 4 can be as it is, 2 can be actually highlighted now. 0 can be actually made 0 because 4 plus 2, the chip knows, okay, it is 6. Okay. So 1, 0. Okay. Now, I would like to ask you, like, how can we represent number 7? Can anyone tell me how we can represent number 7?
Please,
Okay.
your screen is off.
Yes, I've seen that. Yes, cool. Sweet. Okay, so you can see here, right? This is how you represent number 0, 2, 3, 4, 5, and 6. Okay, now my question to the class is, how can you represent number 7? Okay, how can we represent? Question. How can we represent number 7? Please go ahead and just try to tell me, like, how can we represent the number 7? Take your time, just think the logic, and then you can tell me. I will wait for 1-2 minutes to see.
Hey, Rama, please, can you repeat the question again?
Yeah, I posted in the chat box. How can we represent the
Good.
number 7?
To represent number 7, I guess you'd just, yeah, 1 0 1 1 1.
Yes, right. Super. Yes. 0, 1, 4. 2 will be also 1 because 4 plus 2, 6. Now 1 will also become 1. So 4 plus 2 plus 1, which will be 7. That's right. You got it. So it will be 0. 7 can be represented as 0, 1, 1, 1. That's good. Now, how can we represent the number 8? Anyone can try? How can we represent the number 8?
Hello?
Yeah, go on.
Yeah, to represent it, you just remove the zeros and then so it'll start. You just put the one at under the eight, so it'll be 1000.
Right. Yes, super. Good work. So it will be 1000 because you already have the number 8 here. So you can say 1. There's no need for you to add anything, right? 1 like that. Okay. So yes, you're right. So I want also the others to please try. I think OG has done a wonderful job. I think you can also, everyone can do. Okay. So now how can we represent number 9? Second. Okay. Now how can we represent the number 9? Okay. Angel and Christabel, I am looking for you guys to actually, try. How can we represent the number 9?
Okay. So the number nine will be 1001.
Super. Yes, you're right. Because it will be 1001, which is 8 plus 1 is equal to 9, right? Super job. So to get number 9, you will have to say 1001. Okay. So last and final. Okay. I'm just going to ask you the last one. Okay. So who told this one? Is it Angela? Is here my background is noisy? Okay. So Angela, is that you have said it, right? Okay. Christabel, I'm not sure whether you have tried, but I hope you will try this one. Okay. So please tell me, how can we represent the number 10? How can we represent the number 10? 11, 12, 13, 14, 15. Right? So because you're counting from 0, not 1, the maximum numbers you can represent is 16 numbers, because 0 is also a number, right? For the computer, 0 is also a number. For a human being, 0 might be worth nothing, but 0 is actually something for the computer. It's like the most important number. Okay, so because you're starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, the total numbers you can represent is 16. Okay, so 16 is nothing but 2 to the power 4. Okay, 2 to the power 4 is equal to 16. Okay, so that's how you can represent number 16. Okay, now what happens if you add one more thing? So let's say I want to add one more bit. Okay, now we are talking only 4 bits, right? So this is 2 to the power, so 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Now I'm talking about 2 to the power 4, which is 16, right? So now I'm talking about 16. Okay, so 16 plus 15, how much is it? 16 plus 15, 31, right? 31 plus 1, because you can represent 0 also. Okay, so 32 is the maximum. Is it 32? 16 plus 15, yes. Yeah, so 32 is the maximum number that you can represent with with the 5 bits. Okay, so similarly, let me take this away from okay, so generally the least number, I mean the least bit is actually 8 bits. Okay, so generally we talk in 8 bits, especially for Solidity. We are not talking about any other programming languages, but generally for Solidity we are talking about 8 bits. Okay, so 1, 2, 3, 4, 5, we need 3 more.
Obama.
Yeah, oh, is it?
Yeah.
Oh my god, this is very annoying. I really don't know the problem, so I can't really fix it, but yeah, thanks for letting me know. I'll try to resolve it for the next week. I'm not in a mood to resolve it today, but yeah, for next week I will be doing that. Okay, so 5, 6, 7, 8. Okay, so 16, this will be 32. Okay, and this will be 64. 64. And this will be 128. Okay, so the maximum number that you can actually represent in an 8-bit system. So the maximum number you can actually have in a plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So whatever is the number that you got with the addition of all these things is the maximum number that you can actually represent. Okay, so that's the logic behind it. Okay, okay, generally 8-bit is actually called as 1 byte. So 8-bit is actually called as 1 byte. I'll try to zoom in a bit. Okay, so this is also called as 1 byte. 8-bit is actually called as 1 byte. Okay. 1024 bytes. 1024 bytes is actually called as 1 kilobyte or 1 KB. Okay. 1245 kilobytes is actually called as 1 megabyte. Okay, 1024 megabytes is actually called as 1 gigabyte. 1024 gigabytes is actually called as megabyte, gigabyte. What is after? Okay, let me check. Even I can't remember. Bytes. Sorry, what was it? Gigabyte. Okay. Terabyte. Yes, terabyte. Yes, right. Terabyte. 1024 terabytes. Terabytes is equal to 1 picobyte, something like that. Okay. So these are the different types of things. Okay. So you can see here. So the maximum number that you can represent is actually the 1 byte. Okay. So 1024 bytes is actually 1 kilobyte, 1 KB. So you can actually store an entire book inside 1 kilobyte. Okay. So in 1 megabyte, you can actually store a shelf of books. In a library, you can actually store a shelf of books. Okay. In 1 gigabyte, you can actually, store the information of like 10 shelves of books, something like not 10,000 shelves of books. Okay. In 1 terabyte, you can actually save the entire library. In 1 picobyte, you can actually save the entire libraries in a country. And after picobyte, you have something called permabyte, something like that. So which you can store all the information about all the libraries, all the information that has been ever recorded in the human history, something like that. Okay. So generally Facebook and every other, like the social media apps and other big companies have data in picobytes. Okay. So that's the huge data. Okay. So you can consider this one. Okay. So now this is what we are talking, right? So now we're talking about int. So we are talking about int 8. So we are talking about int 8. Okay. So you know that int 8 is nothing but you can actually represent this huge number either in positive or negative. Okay. So that's what you're trying to say in int. Okay. So if you go here, okay. So if I say 10, maybe 100 is also okay. 1000 is also, so you can see 1000, I'm not able to go to 1000. So you can see that int 8, I cannot store 1000 because is not implicitly convert to literal is too large to fit in int 8. Okay. So I think, I don't know what is like 128 plus 64. Let me once calculate the biggest number that you can have. I think it's something, wait, let's clear everything. Okay. 128 plus 64 plus 32 plus 16 plus 8 plus 4. Yeah. 250. So the biggest number that you can represent is 255 plus 1.
Sorry, I think your screen went off again.
Okay. Sorry. Thank you. 2. This is an annoying one. This is a very interesting class, but our screen is actually making us trouble. Yeah. So what I have done is that I just added 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is 255 plus 1. So you can also represent 0, right? So the biggest number you can represent is 256 generally. Okay. So you can go here and let's check this one. Okay. So 255. 255. Too large to fit. Okay. 254. Oh, 53. 252. What's the number then? 250? 200? Okay, I think it's 128. 27. Okay, 127 is the highest for solidity. Okay, that's the biggest number you can actually represent in int 8. Okay. So where is that? So this is the highest number that you can actually represent in Solidity. But in other programming languages, you can represent 256. Okay. This concept is actually the same in any programming language, but the implementation might vary for some programming languages and for the others. Okay, so that's the difference. Okay, so int 128 is the highest thing that you can actually represent. Okay, 128. It cannot be 128 because you're starting from 0. Okay, because 0, 1, 2, 3, 4 like that you're counting. That's why it cannot be 128. It can be only 127. Okay, for int 8. Okay, cool. So now what is the problem? Okay, so why are we using different denominations here? Like why are we using int 8 or int 16 or int 32 or int 64? Okay, let us study why we are using actually this one. Okay, so I'll copy. And the value is actually 127. So what is happening inside the memory of the contract? So you can see inside the memory, the value is A. Okay, so this is the variable that has been created inside the contract. Okay, variable A contains the value 127. Okay, it contains the value 127, which will be stored inside the value A. Okay, so it will be stored inside the value A. You can see the value. Okay. Value variable A, you can see the value 127. Okay,
No, please, your screen is full.
okay. So the variable a contains the value 127. Okay, now let us see closely. Now you're saying int 8. Okay, so what are you trying to say? Inside the smart contract memory, okay, so inside the smart contract memory, okay, so you're saying int 8, which means that generally you're saying I want a smaller memory space. I don't want a big memory space. Okay, so let's say this is int 8. Okay, so int 8 is very small, and it can actually save the number 127, which is okay for us. Okay, so int 8 is very small. Now the second actually int 16, which is actually bigger than int 8. Okay, so it will be a little bit bigger than this one, which can actually take in a bigger number. Okay, int b is actually 16. Okay, and then you said int 32, so it will actually create a much more bigger number or bigger memory space. Okay, so the yellow ones are the memory space in the smart contract. Okay, so int 16 will become int 32, and then you said int 64, so int 64 is bigger than all of this. Okay, so you can see this is a bigger one. It's almost the double of the 32. Okay, so this is ABC T. Okay, and then you said 128. Okay, you said this as 128, and this is much more bigger. Okay, 128 A B C D E. Okay, so you have this space. Now what you have said is that you have said int 256. Okay, you have said int 256. Now by default, okay, just remember this, by default every int is actually int 256, the maximum value. Okay, so if you have said just int, or if you even said 256, that's one and the same. Int and int 256 is one and the same. Okay, so when you said int 256, what will happen here? So you can see here, when you said int 256, it is actually bigger, very big. Okay, so this is very big. A B C D, yeah, 256. Okay, now you see the problem here, what is happening. Okay, you see the problem, what is happening. You can actually store this because you already have this memory, right? So you cannot really store this value into the smart contract, because smart contract, the maximum stuff that it can take is, but you cannot the smart contract. For Solidity smart contract, the maximum it can take is 1 megabyte of data. Okay, of course this is not 1 megabyte of data, but I'm just giving you an example. Okay, because if you have a very big code and everything will be converted into machine code, and that machine code should be actually saved in this structure, right? So if it is a very big memory code, what will happen? You do not have the space to actually keep this thing into the smart contract. So what will happen? You will get an error here. So this will be shown as a, so this thing here will be shown as an error. Okay, I can't can I change the color? No. Okay, cool. Okay, so you can see here, generally the maximum number that you're representing is number 10. So there's no need for you to have int 16, int 32, int or anything. So you can, what you can do, you can say all are int 8. If you need a bigger number, you can use that specifically. Okay, so you can say int 8, and the memory gets, you can actually use a less memory, which means that you have more space. Okay, so you can actually have more space here. Okay, this can also be reduced to smaller units. So this can be also saved in smaller ones. So this is also will become a smaller one. Now you can accommodate even this one here, okay? And you can still have this much space for other things to do, okay? So smart memory, okay? So if you generally do int for everything, yeah, I know that it has been closed. I'm sharing it again. Yeah, is adding space, but you're using only number 10. So to save the memory, you can actually use this kind of stuff, okay? So that's what happens. Okay, so if you are using everything like normally, you can actually save a lot of energy, a lot of gas, a lot of memory. Okay, so you can see the example over here. Okay, so I'm saying int 8, 16, 32, 64, 256. But if I say generally int for everyone, okay, let's say int for everything. Okay, let's say int for everything, very small numbers. Even for the small numbers, I'm saying int. Okay, I will deploy the contract and I will show you what will happen. Okay, so when I'm deploying the contract, I got the success button. Okay, so you can see gas is this much. Okay, this has been the consumed gas. So you can see 3,59,000. I mean 35. I don't know how you say, because we have something called lakh 440. It's a very big number. Okay, like 500,000, something like that, right? But instead, if you set something like int 8, this is 8, this is 8, this is 8, this is 8. Okay, so if you have done all these things, okay, so the maximum number that we have seen here is this one. Okay, so I'm gonna copy this one, copy this. Okay, so I'm gonna do all 8, 8, 8, 8, 8, 8. Now I'm gonna deploy this one here. Okay, so deploy, and I'm gonna see here. So you can see this is much lesser. So you can see the difference when everything is okay. The gas has been actually consumed less than all are ints, and in here this is all are int 8s. Okay, even when you used all ints, it worked. Even when you used int 8s, it worked. But the gas, you can see the difference. Okay, so instead of paying a lot of gas, you actually did this one. And also you see, when you actually try to use the smart contract, when you're using this kind of stuff, it will be much more actually. So you can see the execution costs are very, very low. Okay, so this is what happens so you need to save the memory inside a smart contract. Okay, so that's the reason why we are using int 8 or int whatever the things. Okay, depends on the number. If you're actually using a very small number, don't try to use int. Instead, you can be more specific and say maybe int 64, int 28, or int 128, something like that. Okay, if you want to deal with big numbers. Okay, does that make sense? Now, why are we using int 8 or int 32 or whatever the things? Class, does it make sense? Did you understood the concept? Yes, Oji, thank you. Angela, Christabel. Cool. Okay, so generally in other programming languages, it can be more okay concept, like you can represent in specific numbers. Okay, so this is even concept of other int. Uint is also same. Okay, here programming language you can either have minus 127 also. So you can also have minus. You can also have minus. But for uint, you cannot have that one. Okay, so uint is nothing but unsigned. Okay, that's the only difference. So you can see you can have minus. Okay, you can have minus. But for uint, you cannot have minus. Okay, sure. This is the concept of uint is nothing but integer data types in Solidity programming language. Okay, so yeah. Cool. Everything's working fine. So this is unsigned integers, and these are the uint. Uint can only have positive numbers like uint 8, uint 16, something like that. Okay, so you understood the concept. Okay. I think I need to delete the Discord channel, and again I have to do it. For next week, I'll try to do that. Update the Discord app. Okay, so these are the concepts. Now let's go to the concept of Boolean. Okay, so let's go to the concept of Boolean. So maybe I think before going into that one, you can actually use this in your programming, in your things. Okay, so I have pasted the code in the chat box. Try to copy that and try to paste it in your computer and try to do some sort of like maybe try to yeah, run it. That's it. Just try to run it so that you can have the code. Okay. Once you have done, please let me know. Once you have done, give me a thumbs up. I'm gonna just bandwidth. Thank you. I will be waiting for others to just give me a thumbs up and then we can continue. Okay. Well, thank you. You have done it. Yeah. So I'll wait for Angela to done and then we can continue. Cool. Angela, I think is everything okay? Okay, I'll continue and we can see. Okay, so I'm going to create a new file and I'm going to name it as boolean.sol. Okay, I'm going to again do those things. Okay, so the first two lines, you know that, this is simply the same thing. Okay, and this will be boolean example. Okay, close string. This is getting annoyed day by day. Okay, I'll just try to cancel everything and again rejoin. Just give me a sec. I'll just try to come back again. Just give me a minute, okay? Okay, I'm back. Let's see if this works fine. I think I need to update my Discord. Okay, cool. So now we are talking about Boolean. Okay, so if you go here, the next topic is actually something called Boolean. Okay, so Boolean is nothing but it's just either yes or no. Okay, so Boolean means either yes or no, or we can also say 0 or 1. Okay, so 0 or okay, so that's the logic. So we are talking about again variables. Okay, we are only talking about variables. In that we are talking about Boolean data type. Okay, so in variables we are talking about Boolean data type. So how can we do this? Okay, so we can say bool like I'm saying bool public like football. Okay, is equal to true. Okay, so you can see here the bool like football. I can say maybe he likes football. Okay, so this is actually he likes football. The answer is true. Okay, it can also say if he likes football. Let's see. Just give a second. I'm just thinking about a really good example of Boolean how thing can be used. Okay. And what can I say? What can I say? What can I see. Yeah, not this one. Okay, maybe let's go here. I want to go with some sort of an example. I already done some examples in another browser, so I just want to copy and paste that one. Remix. Bytes, fixed arrays, library, signed, mapping, structured, address, visibility, constant, Boolean. Yeah. So this is a good example. Okay. So this is a good example. Okay. This is also, I think, returns. Okay. Return A is functions removal restricted to view. Okay. View. Okay. So again, don't bother about what I'm trying to do here, okay? Because you will understand all these things in the coming classes, functions, how to use everything and this, okay? I just want to show you how we can use Boolean, okay? That's it. Pa, 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 pa. Yeah. Okay, let's do this. Okay. So, likes football, and this is say team A score, team B score. Okay. So if team A score this becomes likes football is equal to and this will be this function can be declared as okay, cool. Okay, so again, don't bother about what I'm trying to do here. Okay, I'm just trying to show. Okay, so don't worry whether if you don't understand anything here. Okay, so the first two lines, as you already know, like the same things. Okay, the license contract. Okay, so this entire thing is a contract. So this entire thing is a contract. Things that you do is that you actually try to write variables. Okay, so now you're trying to write this variable. So you can see here, if you read this variable properly, this is a Boolean data type. Okay, so data type is bool, which is the short form for Boolean. Okay, so public is a visibility parameter. Public is a visibility parameter. what is visibility parameter I have not explained to you. I'll explain in the after classes. Okay. Now likes football is the name of the variable. Is my screen shared? Yes, good. I'm just checking. Okay. So Boolean is the data type, which is nothing but it can take either, this can take either true or false. Either it can be a true condition or a false condition. Okay. So likes football, something like that. Maybe instead of saying likes football, I would say won game. Okay. I would say won the game. That makes more sense, right? One game. Okay. So I'm actually creating two variables here. Okay. This is also variable with the name team A and team B are also variables. Okay. And you can say int public. Okay. In public, the score of team A. So team A score is 10, team B score is 20. Okay. So this is called a function. Now function is a very lengthy concept to explain. I will explain you in the later classes. Okay. But what I'm trying to do is that I'm trying to write a condition here. So condition to show who won the game. Okay. So don't try to remember this thing. I'm just trying to writing a condition. So the condition is one game. So in this variable, I'm going to check who actually won. So team A, the team A score, is it less than team B score or not? Okay. So I would say team B. Okay. So the score of team A, is it lesser than team B or not? Okay. So if it is yes, then just return one game, which is nothing but true. Okay. So you can see here the value of team A is 10, the value of team B is 20. So this means it is actually 10, 20, which means this is true. Okay. So which means this is true. So this will return actually true here. Okay. One game will be actually true. Okay. So you can see here when I try to deploy this one. Okay. So you can see the score of team A is 10. Okay. You can see here team B is 20. Okay. Now check the condition. So I'm actually trying to check whether team A has won or not, or team B has won. Okay. So when I check the condition, you can see it is true because 10 is actually flip the scores. Okay. Let's say I'm going to flip less than 20. So what scores? 100. Okay. So what if I have done that one? You see here team A is 100, team B is 20, right? Which is less than. So this will also become false. Okay. So you can see here, I have written the check condition and this. Okay. So Boolean is nothing but it can either take, okay, true or false. That's it. So using this, we can actually guard something. Okay. So in the real world, how the smart contract will be using Boolean is that, okay. So in the real world, just say, let's say, okay, you are the owner. So owner of a particular smart contract. Okay. So this is your smart contract, your own smart contract. Now, when you want to enter into the smart contract, so the condition is when you enter into the smart contract, you will write a condition where only if I am an owner, which is true, then only I can enter the smart contract. If I'm not the generally used, so Booleans are generally used for this kind of a logic where only required people with the permissions can actually enter into a specific area. Okay. So that's the logic behind bool. Okay. So this is one data type. Also, I'm going to copy this and write it in your here. So why am I actually trying to do all these things is that so you can actually have the code. Whenever I'm trying to do this one, you can have this code in your computer so that you can actually practice that. Okay, because from tomorrow you'll be again meeting again on Wednesday, which you will have like 7 days time. So I want you to just look into the code, practice it. Maybe you can ask AI to explain that in an easy way, something like that. That's why I want everyone to have the code. Okay, so this is the code that I have pasted. Again, try to run the code in the platform and let me know. Okay, so this is the code. You can copy it, save, run it in your computer, and just let me know. That's it. So this is Boolean done. Address. Next is address. Thank you, Oji. I will wait for others to complete and then we can start. Angela and Christabel, I'm just waiting for you to complete and then we can continue.
I'm done.
Oh, okay, cool. Thank you. Thank you. So yeah, Angela to confirm and then I will continue. Is it because of anything like this? Um, Okay, okay. I think something is running in the background of my computer. That's the reason, I guess. Okay, cool. Angela, just are you here? Is everything okay? Cool. I will continue because I think we just have like 15 minutes to complete the next topic. Okay, so I'll just complete one more thing. Yes, okay, cool. Thank you, Angela. So I'll complete one more topic. Okay, I know that this is too much for you guys, but we have like a very limited time, so I'll complete one more topic and then we can say a day off for today. Okay, so just one more topic. Okay, so now the next topic is actually about addresses. So we learned about signed integers, unsigned integers, and Boolean. So Boolean can have something like yes or no, true or false, right? True or false. Yeah.
Your screen is off.
Yeah. I'm just trying to set up few things. That's it. Cool. Thank you. Okay. I think you can see now. Okay. Yeah. So you can see that we actually learned about signed integers with all these things, also unsigned integers with all these things. Of course, I have not written uint 8, uint 16, everything, but like what we explained. Okay. Boolean have either true or false statements, just conditions. Okay. So it's called conditions. Now the next topic is actually address. Okay. So we are now talking about the address data type. Okay. So for that, I have created something called address.sol. Okay. Again, the first two lines I have written. Now contract, I have written address example. Now I'm going to write this one. Okay. So I have written variables again. Every time I will be writing variables. Okay. And then address is the data type which can take addresses. Okay. Public is the visibility parameter. Is the visibility parameter. Add 1, add 2, or address 1 or address 2 are the variable names. Variable names. Okay, so address, public, add 1, address, data type, which is address is the data type, public, add 2. Okay, now this is a function. Now you can see there are coming something called a concept called function. Okay, so function is a very, very important concept. You will learn that during the course, but functions are very important, not just for Solidity, but for any other programming language. Okay, so generally now you're learning not just Solidity, you're also learning about programming. Because of this, you can actually understand other programming languages, the concepts. Of course, the syntax might be different, the way that they write is different, but you can understand now like what is a function, what are variables, what are integers, what are floating numbers, what are strings. So you can understand these concepts now. Okay, slowly you will understand the basics of program, understand other program. So what I would suggest is that once you have completed the Solidity course, then maybe also try to learn any other programming language, because now it will be easy, little bit easy for you to understand. Okay, coming back. So the logic here is to add addresses to the variables. Okay, so just don't worry about this logic, okay, because you don't know like what is a function and all these things. I'll explain that in the later classes, but the logic here is to add addresses to the variable. So you can see I have compiled it. So when I click on compile, this will be compiled. A shortcut is instead of going this and clicking on this button, you can also click Control yes, which is Control save. Okay, that's a shortcut. There's no need for you to go every time here and try to press this button. So you can just type. So you can keep your mouse here, and then you can click Control yes, and it will be automatically compiled. Okay, here, properly see here. Okay, so you have deployed the contract. You have actually got the contract. Okay, you have actually got the contract. Okay, Now you can see this set address. So because I have did this one, I'm actually can do here address 1 and address 2. I can actually give some values to it. Okay. Now, before going into the topic, I want to ask the class, because we have already done this. What do you mean by an address? What do you mean by an address in the context of blockchain? What do you mean by address in the context of blockchain? Yeah, I also posted the question in the chat box, so you can see and tell me, like, what do you mean by an address in the context of blockchain?
Hello?
Yeah, go on, Oji.
Yeah, I guess an address is where someone receives um money or something.
You are right. You're not wrong. You're right, but you're like 90% right. There is one, you missed 10%, but you're right. Yes. You can try again, or maybe, yeah, class, anyone can try. What is an address? I think we discussed that a lot. Anyone, any guesses? I'm just seeing like whether anyone can answer, but okay, cool. I will try to answer it. Um, so you can go to day 1, right? I'll go here. You see there is an Excel sheet where I can write my name and how much I own, also the name of OG and his like angel and this one. Okay. So now what happens when this kind of a thing exists? She has, when everyone can see what is your bank balance, what will happen? People might try to kidnap you, or maybe they will try to, take ransom from you or something. They will try to bother you because you have the money and they want to take your money. So what will they do? They will try to, bother you. They will try to force you. They will try to do something else. Okay. So they'll try to do all these things. They want you to give their money. Okay. So that you, so for this reason, okay. So for this reason, what we will do. So instead of our name, it will be encrypted. Okay. So I think I have already showed you that encryption. 256 algorithm. Mhm. So you can see here, my full name is this. Okay. So this is my encrypted name. Okay. So this is my encrypted name. Okay. So this encrypted name is actually called as address. Okay. This is my address. Okay. So this is where if you want to send the money, you can send the money. And this is how you will be actually receiving the money from. Okay. So if you go to a platform called Etherscan, you can actually check all these things. Okay. My screen. So and so address. So this could 0.0. You never know who those persons are, but it is encrypted. So you can never know who that person is. You can only know that, okay, this person, so and so person has done something. Okay, but you don't know who Satoshi Nakamoto. No one knows who he is. Public, no one knows who is doing what. Okay, addresses are nothing encrypted values. So these are called addresses. Okay, this is what you have in block. Addresses. Okay. Cool. So you also have these addresses. Okay, so these are dummy addresses. In real world, it might be real money, but these are dummy addresses. Okay, so you can see this is an address, this is an address, this is an address. So all these are addresses. Okay, so I can select this address, I can copy this address, I can select another address, I can copy, entered one address here and other address here, and I told to 2 here. So now you can see this is the first address and this is the second address. Okay, so you can see something like it cannot take number or it cannot even data type, so your address will be okay. So this is what it is. Okay, so this is the address data type. 1 second. Cool. Okay, so this is the logic behind address data type. So you have account like a you can between an account and a contract and a smart contract. Okay, but it's generally that's how blockchain works. Okay, so I'm gonna again do the same. I think this is the last concept for. I think this is too much information for one day, one class. Okay, I have pasted the instructions along with the code and everything. Okay, so once you have done, I will finish the class.